Sorry.
No, you're
You
good.
could probably pop it up.
Yeah.
You got these?
It's gonna have to be.
Oh, okay. We're almost live. It's still ringing.
Today is going to be decided for me. I'm going to make my mind up today.
John, how much was this headset?
Enough.
It's pretty dope.
150 or something.
Alright, we're almost there.
Hey, you have somewhere I can mirror my phone to your TV?
For videos?
Not videos, but pictures.
Pictures? Yeah. We can
That's
do
kind
that.
of a big part of what my
That's fine.
presentation.
I got it. Chrome, you know how to use Chromecast?
Yeah, I think I even got it.
Okay.
I mean, I've never used it, but I have it. I was trying to one time.
John, I don't want to start live streaming if we're not set up yet.
It's
No, you're
happening.
supposed to live stream so that people can see what it's about.
They start
You already
getting there.
Yeah, it's okay. People got to get on anyways, so
Yeah, okay.
it'll take time. Oh, sorry.
Oh, maybe.
So what'd you handle title this thing
What?
on your stream?
Flatter at the bit.
Okay.
Oh, so when you stream, it's saved on your thing?
Yeah.
So people can watch it later.
So which one should I download? There's a whole bunch of Comcast.
No, it shouldn't be like that.
I think
Well,
it's
here,
like
what we'll
Google-
do,
Google
I'll Chromecast from the TV. Pull up the photos that you want. You have them somewhere on a website?
I haven't screenshotted.
Did you close out of those two pictures I had, John?
All cast.
No.
Right.
Okay, good. Here, we can cast these.
Can we send the lays this way?
Nah, man.
How do you have them screenshotted?
Yeah,
On your phone?
yeah.
Alright, switch to your, text them all to me, and then I'm gonna Facebook them to myself. Oh no, shit. John, I need my phone. I need my red one.
Take it.
Yeah, we shouldn't use phones right there.
Alright, text them all to me,
Get those out.
on my work phone,
Corn out.
and then I'm gonna Facebook them to myself so that we can pull them up on the computer, and then it'll Chromecast over to that.
Alright.
What do you think that is?
A pizza.
That's not a pizza.
That was a pizza.
Pizza doesn't look like that.
Alright.
I got a lot of pictures here.
How do you know what pizza looks like? See? Question.
What?
Exactly.
It's got the crust on the outside.
Oh yeah. There we go.
On the inside.
You have to probably just alleviate more.
Mm,
Yeah,
yes.
that'll work. Like honestly, stick like a little notepad or something right in front of it. Oh, maybe not something hard like that.
Oh, John, I can see you.
Is that my good side?
Yeah.
What they said.
Oh, that's perfect.
Yeah?
I'd say a little bit to the left, though.
Well, you can shut. A little to the left.
A little to the left, a little to the right.
How long is the delay?
Instant.
So
5 seconds or so.
Just got done moving
Instant.
So
it.
John,
It's not instant.
Instant.
I need you, we're gonna put all the things to put here, and then whenever to cast,
It's like
you'll just copy the link, put it over here. And this will
Oh,
be,
yeah.
alright, and then
That-
cast it.
That's casting.
Yeah. Alright, so we got casting up. You text them to me?
No, I'm working on it. There's a bunch.
Alright, we're almost there. Well, we don't need, you can start texting them to me, I'll put it on silent, and then I'll forward them to myself, so we'll be ready for your speech. I'm gonna go ahead and start.
That was like.
Okay, so, Jason, you ready?
How would
Clock is
you
going.
find
No,
your
start,
channel?
hold on.
Stop.
How would you find your channel?
Biscuits and crazy, all one word.
Freaking crazy.
Alright guys, I'm going to preface this debate with, please, and I think Mike will agree with me on this, keep an open mind. That goes both ways. If you truly believe the earth is flat, please, keep an open mind to the earth not being flat. I know we've all done research. I know people that are online have done research in both directions. Don't set your mind to one idea. Flat, round, we're going to figure it out today.
Pear shape.
Yes. Okay. So, that being said, we're going to start. Ready? And cool, 30 minutes. Here we go. All right, guys, I want to talk about a couple different things right off the bat. We're going to go down the road from vocabulary to perspective, math. I'm going to not really touch on that a lot. Experiments, and then the government. So, vocabulary first. This is the most important part of the entire thing, I believe, where we need to start. It's the bedrock, the cornerstone of this debate. A couple ones I want to talk about: gravity, buoyancy, and density. Gravity being the obvious one that we need to talk about the most. If you are a flat earther, you believe that the earth does not have gravity. You think that the earth is flat. The issue I have here is not with whether or not buoyancy, up or down, things like that. The issue I have is that something has to create a force. Something has to make something go down. Otherwise, the objects would float in space. There is an up and there is a down. We can all agree that when I drop this packet, it goes to the ground. And we can agree that if I drop it from a higher altitude, it will go down quicker. If you drop a Coke can from 6 feet off the ground, it does not explode. If you drop a Coke can from 30 to 40 feet off the ground, it explodes. Something causes it to move downward and move down faster than normal. If it's heavier, if it's lighter, it does not matter. All things go down. So, the question that I have is, what is that thing? What causes those things to go down? Everyone in the globe world, everyone in heliocentric ideas think that this is gravity. They say that that's the term they use. Flat earthers say, no, that's not it at all. It has to do with buoyancy or density or X number of things that Mike will probably talk about going forward. I do not care if something is buoyant. I care about what causes it to be buoyant. I do not care if something is dense. I care about what causes dense objects to fall. Buoyant, dense objects still go down. What is the force that makes it go down? You don't have to call it gravity, but you have to call it something. And it does exist. Because we do go down. Like, I am attached to the ground. I'm not going up. I'm not being hurled left. I'm not being hurled right. I am going down. Something keeps me to the ground. So, on to buoyancy. The ability to float. I think that this is a big misunderstanding of the definition of buoyancy. Buoyancy is less dense objects over lighter dense objects. For instance, I'm not falling through the ground right now, even though I'm just as solid as the ground. It has nothing to do with buoyancy. It has to do with the fact that we are both solid mass objects, and I can't phase through the ground. If you put yourself into something viscous, like water, put a ball in something, a hard rock hits the bottom of that cup with water, whereas a ping pong ball does not. It is more buoyant. It has nothing to do with up is up and down is down. Both objects should either stay on top or fall to the bottom. The reason why they're not is because one is lighter than the other. What causes lighter things to go up and heavier things to go down? Something, not buoyancy, because buoyancy is the actual effect of it happening. When I say that a cup full of water holds a ping pong ball on top, that is a buoyant cup, or that is a buoyant ping pong ball. It is being buoyant. What causes it to be buoyant? That's what I ask when I say gravity. Same thing applies to density. Both of these definitions below gravity are explaining what something is. It is more dense. It is more buoyant. It is less dense. It is less buoyant. My question is, what causes more dense, more heavy, less buoyant, less light creatures, less light anything? Birds, planes, whatever you want to point to. What causes up to be up and down to be down? Some sort of something. You do not have to call it gravity, but you do have to call it something. Now, below that, we have both the heliocentric idea of what the Earth is, terrible drawings, I know, and that's me, the flat Earth idea, which is the widely agreed disk. Obviously, there's multiple, but go ahead. Who is it?
It's Conroe.
I didn't ignore it. The flat Earth believers widely agree that this is what we're looking at. Now, I have a lot of measurements on here. I don't know if you can tell from the video, but what the reasonable agreement is from the consensus of everyone that thinks the Earth is flat, everything I could see states that the sun is anywhere from 3,000 to 5,000 feet or miles above the ground. The equator that heliocentric people believe is the center of the spinning Earth, but flat earthers still believe is, somewhere where we can at least get to, is in circumference around the North Pole about 25,000 miles. And again, these numbers could be widely disputed, 5,000 in either direction. We don't really know, according to flat earthers, because these are all numbers given to us by the government. And the last one, C, which I measured here, the center from the North Pole to the ice wall that we know of is roughly 10,000 miles. Now, go ahead, John. Sorry. You gonna hold it for me? Yeah. Thank you, sir. Now, with these numbers, I want to point out a couple things, but I'm not going to get there yet. We're going to go now to the globe Earth, where we have some other numbers. The globists believe that the circumference of the Earth is 24,000 miles. The radius is to the core of the Earth is roughly 4,000 miles, 3,959. The diameter from one edge to the other edge is about 8,000 or 7,918. All these numbers can be Googled. It's the first number that pops up. It's what everyone consistently agrees on. From the sun to the Earth, this is where it's very important. We believe, as globists, that the sun to the Earth is 92,960,000 miles. Now, that does sound insane. I agree. That's a lot of miles. But perspective-wise, I ask you, and this is why I get into the second thing I want to talk to you, which is perspective. Personally, right now, wherever you are, videoing this, sitting in this room right now, looking at this, you can put it down now, John. Looking at this, perspective is a very important thing. If you look to a corner of a room, does that line not seem to go off into the edge of the room? If you look at a railroad track, if you look at the edge, if you look at the horizon, everything you see seems to vanish into one specific point on the horizon. What I ask you is if something is the bigger something is, the more obvious it is that you can see it. A mountain in the distance looks to be the size of a penny, but when you get up close, it completely fills your field of vision. That mountain is now bigger than anything you've ever seen because you're right up next to it. What I ask you is that if something was 92 million miles away, for you to be able to see it, would it not have to be an enormous, I mean fucking huge, giant ball in the sky? So, I'm not asking you to believe the Earth is round right now. I'm not asking you to believe the Earth is flat. I'm asking you to just go off of what globists think the measurements are. If something was to exist 92 million miles away, it would have to be, as the internet says, the sun, I don't even have the circumference on here of the sun, but it would have to be millions of miles wide for you to be able to see it. Otherwise, just like a mountain in the distance, you would barely be able to notice it on the sky. Now, that I'm just going off of what globists think right now. For these things to exist the way that globists think is possible if you believe that that object is that big, you can see it from that far away. If a mountain is massive, you can see it from a further distance. Not because it doesn't exist or it's a hologram, but simply because it's so big that you can see it from a further vantage point. Here's my point with this, is that a lot of the big problems we have between flat earthers and globists is perspective, and rightly so. If we are to live on a planet that is, even if you look at it from the flat earth perspective, 10,000 miles from the North Pole to the ice wall, that's an impossible field of view. Even on the clearest day, you can't see that far. As you watch planes fly off into the distance, as you watch the horizon go off into the distance, nothing that anyone has ever been able to observe on the ground has ever reached to 10,000 miles. Nobody has. From where we are right now to the next closest metropolitan area, it's at least 30 miles, 40 miles. When I say that, what I'm trying to show you is that right now, I can't see the buildings downtown. And even on the clearest day, I can't see them. Whether it be from elevation, globe being round, globe being, or not being a globe at all, being flat, it's not visible. So we need to talk about perspective in things that we can't see with the naked eye, that we can't see even with a telescope, because they're so far away. These numbers that we're talking about for a flat earth, 3,000 miles. All right, perspective-wise, to walk, which is proven to go from Florida to Seattle, is over 3,000 miles. All right, we're talking about the entire distance of America for even what the flat earthers think, let alone what globists think. All right, so it's very important that we talk about perspective. I'm going to get back to that a little bit when we get to math. This is the part that I'm a little confused on as far as when I did my research into flat earthers. If we were to draw lines from directly above where the sun is on a flat earth model, which I have right here, I don't know if you can see it. Yeah, you can see it. Okay. If you were to draw a triangle from the point directly below the sun to wherever you are on the planet, and make that exact perfect square triangle up to where you're looking at the sun, and do the math, which is common Pythagorean theorem, you would deduce that there's no possible way mathematically to prove that the sun is 3,000 miles away. Now, I'm not asking anyone in here to do a lot of math. I'm asking in here just to do simple stuff. If you were to go home with a calculator right now, and I ask all of you to pull up the calculator on your phone, and look at a triangle where one side is 3, one side is 4, and the angle is 5. The math to figure out the angle on a triangle, so let's call the angle C and the other two sides A and B, is C equals the square root of A squared plus B squared. Or A squared plus B squared equals C squared. Okay? So if you square 4, on this triangle it's 4, 3 on the straight sides, and on the angular side it's 5. If you square 4, it's 16. Square 3, it's 9. Both of those combined, added together, is 25. 25 is 5 squared, thus proving that the angle is C. And if you actually take a ruler out and do this yourself at home, you will see that this is actually true. Now I ask you to add a couple zeros to it. If the sun is 3 to 5,000 miles above the Earth, let's say an average of 4,000 miles above the Earth, you are away from the directly, say the sun is setting at some point, and you are roughly 3,000 miles away. The sun is directly over Seattle, and you are 3,000 miles away in Florida. If you were to measure that angle, the sun should now be 5,000 miles at an angle from your visual vantage point. All right? That is physically impossible on a flat Earth model. The reason why I point that out is that if you look at the globe design that all flat earthers believe in, where Australia is on one edge and North America is towards the center of the North Pole, and you look at the surrounding circle that is the flat Earth model, you cannot make these measurements. If you put the sun over North America and put yourself over Australia and take any measurement of what people believe to be the distance between Australia and North America, or walking distance, something like Russia, where you can actually prove, walking across land, how far you have traveled by your own measurements, you can prove that the Earth cannot be that close to the planet. You can prove that the Earth can't be 10,000 feet closer, 10,000 miles closer to the planet. What I'm trying to show you here is that with this model, the sun could not simply be in the same sky if you were on one side of the planet and the other. Now you ask, well, maybe we don't have the measurements right. All right, maybe Australia is closer than we think it is. But I ask you, are commercial airline flights a myth? If you've ever flown, you've been able to see what land looks like from a plane. You've been able to see how far distances are to Florida. I'm not saying that there might be something conspiratorial with airline pilots. There might be. That might be part of the big government conspiracy. But you can go off of what you see. And what you see when you fly in a plane is the distance you travel. When you're below the clouds or on a clear day, I compel any of you to buy a plane ticket and fly from Houston to Florida, from Florida to Seattle, and look at the amount of land that you're passing. These numbers are real. North America is at least 2,800, close to 3,000 miles across in distance. So if we can prove that these numbers exist, we can prove that this distance exists, it is impossible for you to prove that the sun is that close to a flat disk. Now, though it seems astronomically impossible, this sun, we're at 16 minutes?
16 minutes, yeah.
Okay. Though the sun seems astronomically impossible far away, the fact is that it's the only thing that makes sense, because how could it possibly make sense for you to see the same sun in the sky that someone in Australia does when anybody here can pull up the app Snapchat or Instagram and get a timestamp, date, and photo from anybody on the other side of the planet showing that there is no sun in the sky, showing that the sun is down. Now, that is more of an important point right there. We all think that the government, to some degree, does things that are conspiratorial, lies, cheats, does whatever, because it's in the nature of mankind. We all do it. All right? I'm not going to lie to you. Last night, I tried to get a free shot at the bar. It's what I do. All right? Everybody wants a free shot. Why can't we believe that the government's doing the same thing? We can't. But the government's also an incompetent windbag. They screw up stuff left and right, waste trillions of dollars. These are facts that we just know about, that we can observe because the government screws up and we all catch them. All right? What I'm trying to compel you to see in this room, online, wherever, is that we don't need to talk about the government to understand flat versus round earth. We don't even need to talk about what we can visually see. We can just go off of common sense, basic math and show that a ball full of light could not be that close to a planet if things like Snapchat were to exist, if plane flights were supposed to exist, if shipping lanes were supposed to exist, because it would be immediately provable that I could take a photo on a vacation in Hawaii at a specific time, send it to the person on dating day, Mike, and tell him, hey, it's 3 o'clock in the afternoon here, what does it look like where you are? And prove that at the angles that we are at, it is impossible to have the sun be that close to the earth. Now, moreover, on perspective, I know that Mike's going to talk about this as well, so I'm going to just come over here and show you really quick. He made a better one than I did. I actually blocked out a little bit of the light here. One of the big things that, with perspective is corpuscular rays. All flat earthers will have you believe that the sun is directly behind a cloud, which if you look at any photo of any railroad, road, anything going to the distance, you'll see that perspective points to wherever the end of the horizon is. The same thing is true for the sun. If you look at the picture on the TV that I have right here, this is a sun unobstructed by clouds. The light rays coming off of it look like it's directly coming from the sun. Now, if you look at any of the photos that Mike will provide, it looks the exact same way, except it's coming from behind the cloud. Mike has made this lovely little box with holes in it to prove this point, which actually works towards my advantage. You can't see this online, but for the people in the viewing audience here, I'm covering up the light right here to show that little holes are seeping through. Actually, the holes aren't big enough. I'll use mine. So, same thing. There are little holes that I drill through a piece of paper to show corpuscular rays coming through this light fixture. And that's not bright enough either. Anybody got a phone? Turn the light on it. And we'll use this one again. Thanks, sir. All right, this should be bright enough. Alexa, turn off apartment. So,
Okay.
if you notice, as the light is extremely close to the actual box, the light that's fracturing onto the ground is actually very neat and very narrow holes. The closer I get to the holes, though, they get bigger and blurrier. Same goes true with mine, which has slightly bigger holes. The further away I am, the more clear and precise the light sources are. The lines going to those specific light holes are much more precise, and you can actually make them out as rays going to the ground. Obviously, this light on my phone is not nearly as bright as the sun, but you get the point. As I go closer to the actual hole, the hole on the ground gets bigger and bigger and bigger. And in fact, it becomes blurred to the point to where it looks like almost the light is shining through the hole entirely. This is the same thing with corpuscular rays. Mike's going to show you a lot of photos. Thank you. Mike's going to show you a lot of photos with linear lines coming out from behind the clouds. This is more proof that the sun is not behind the clouds. Because if it was directly behind the clouds, the rays coming from that cloud would not be so linear. In fact, they would look like a cone. Not each ray pointing to one specific spot, but instead coming out like a fan and covering the entire ground and not being centralized. This experiment proves that. So, on to the next perspective issue, which is, where are we on perspective? On the next perspective issues, Mike would have you do a little bit of math as well. And he'll tell you that there's a mathematical formula you can go out there to show the curvature of the Earth as it dropping over at, I think, 8 inches squared. That's all fine and dandy. And actually, it's true. I did some research into it. 100%, I agree with Mike on this. The problem is perspective. Again, what Mike's formula is giving you is not actually whether or not you're looking over the curve of the Earth, but the actual curve of the Earth. Now, I've drawn some lines here to show you what I'm talking about. As you get higher and higher from the globe, your vantage point from where your eyes would be roughly would stay the same. These are not the straightest lines, but you can draw straight lines on a perfect circle and do exactly what I'm doing. The difference in distance is not something that's measurable. And when I say that, I mean you, as a human being, have to get so high above the ground to even see a city, to see a state, to see an island. The vantage point of a globe in perspective. The city of Houston, from one side to the other, 30, 40 miles maybe. City of New York, something similar. If the measurements of even the flat earth are true, you would not ever be able to see all of the flat earth from any distance up anything less than 3,000 miles. In fact, this is proven. When the ISS is over 254 miles above the earth, if you look at any of the photos, that, whether you believe them or not, it shows that the Earth's curvature absorbs the entire picture. The only photos they have of where you can see the whole globe are from satellites that are hundreds of miles up in space. There's no photos of humans aside from the ones, again, we're not talking about the moon, but the only photos the government's ever provided where you see the full Earth, they do not provide photos with the humans in them. All the ISS photos show humans or the windows don't show the full curve of the Earth because it's not even high enough to show the curve of the Earth. That's how big the planet is. Now, I want to go with perspective a little bit back to math. If you were to take the circumference of the Earth at 24,000 miles, 24,000 miles, and divide the circle up, or the globe, into 360 degrees, like any normal circle. Basic math. Okay? 1 degree of that Earth would be 67.8 miles. So to see 1 degree shift in the curvature of the Earth, you have to have a viewing point of 67 miles. Not 1 mile, not 2 miles, not 15 miles. And that's 1 degree, not an extensive amount of shift in the Earth's globe. All right? So when I ask you to do these experiments at home, to go to the ocean and look at the curve of the Earth, I want you to pay attention to that and think about how vast globists are saying the Earth is round. And then think about what flat earthers are saying. Most importantly, I want to go back to perspective on one more thing, John. Can you pull over that video and stream it, please, of the Earth, of the sun setting? It's a YouTube video. Alt-tab. That one. Cast that, please. Now, this is the most important one. Any one of you can do this at home, anywhere you go, doing whatever you want. This is, without a doubt, a proven fact. The sun sets. It does not move over into a distance, become smaller, go further away. And if it does shift in size, it's so minimal that the naked eye can't observe it. What I'm showing you right here is the sun setting over the ocean. The most easily visible version of the sun you can have. You can see the water reflecting off of it. You can see the mirage where it's showing part of the globe. And then yet, instead of just getting smaller and going further away, it goes down. And I'll let this run. This is in real time. It goes down underneath the ocean. If the Earth is flat, going down makes no sense. Your perspective lines would not match up. It simply wouldn't make sense because think of yourself on a flat plane. As you watch planes disappear into the distance, they don't go down. The sun does. For that to happen, it has to be so far away and so massive. Otherwise, this 3,000, if you try to think of it in this 3,000 format, it would never make it. It just simply is impossible. Vantage points don't prove it. You can literally check people's Snapchats all over the globe right now in your own phone and get a general recognition of where the sun is right now in respect to you. It proves that the sun physically couldn't do this unless the Earth was round. How on earth, I ask you in perspective, does that make sense? Okay, on to a couple more things. The government. We all agree that the government screws up some things. The Gulf of Tonkin is a proven farce created by Nixon. There's all sorts of stuff with the JFK assassination. Whatever conspiracy you believe, it doesn't matter. The most important part that we need to pay attention to right here is the idea that this could be a cover-up. If you don't believe anything I said, and none of it makes sense, and you still think the Earth is flat, I compel you to ask, how could how could more than a dozen governments, over 20 to 40 different private entities, and multiple thousands of people be all in on it? I ask you, I'm just going to pull up some basic numbers. The first object in space was in 1942 by Soviet Russia. All right? The U.S. federal government employs currently 2.7, the federal government, not the military, not anybody else, employs 2.7 million people at an average salary of $57,000 a person. All right? I ask you, in what world does a GDP have enough any kind of gross domestic product of any government anywhere on the planet have enough funds and money to be able to either pay people to keep people silent or bribe people to keep them silent about such an extensive thing? NASA's budget isn't a lie. You can literally look up all the documents showing where funding goes to the government. And even if you believe there's a secret organization that's paying people in NASA to keep these things silent, I compel you to ask yourself, what is the more plausible thing?